Okay, we were talking about SQL joins last week, and we took a look at some joins. Let's see. Where I am looking at customers, customer name. Okay, so select star from orders. So orders dot order ID, orders dot customer ID, and customer dot customer ID from um, orders and customers. Now, if I try to run this, um, assuming I'd spell, this comes back with however many orders there are, 196 times the number of customers, 91. So we get 17,836. This is where you have to join these tables together. Otherwise, it doesn't know how to link them. And we talked about that. And this is where you can do where orders dot customer ID equals to customers dot customer ID. Comes back a lot faster and finds out the number of records it should have. Orders 196, there's 196 here. Okay, so we're continuing on with that discussion. This talks about types of joins, and I'm not going to sit there and read that off to you. Inner joins, that's implemented using only 3 possible join clauses that use the following keywords in different combinations. Natural join, using, and on. And got cross joins. Outer joins. Okay, so and again, I'm gonna let you read that, but this gets down to here in some examples. Now, I don't really like their join syntax on this. You can use it if you want. You see here, using this select region name from regions, join countries using region ID, where country name is equal to Canada. By using the join here and using, that sets up a direct connection between the tables. I like, and I think I don't know if I have an example of that or not. Let me do one. See if I can remember the syntax. Join my region using region. I got something on there. Let me see what the syntax is. Close. Close using region. Now I had my sales, and then I created um, a new table called My Region. And My Region doesn't have much in it; it just has region and then the description. I was talking about I was going to create those so we could have those to look at. And then it goes ahead and joins these. So it's a kind of a shortened way. You're joining these two together based upon the region. Now I notice you just have Eastern here, and I don't have anything else. If I were to bring up, there it is. If I bring this up, you see I just have one record in there. So if there isn't a corresponding entry there, then it won't bring it up, so that it potentially excludes some records that maybe you wanted. You have to understand about how joins work to make sure you're pulling the right data. Now another one is West, maybe, I'm assuming. Western US. Now you see it pulls the West records. This is the problem: is that if you allow them to put in a region that does not exist, that's not my join though. Let's see. There we go. If you allow them to put in a region that doesn't exist, then it may not appear on reports, and so your sales numbers might be off. So understanding the relationship between tables and how to do joins and so forth is pretty critical. It's a difference between you giving them reports that are wrong or programs that are giving the wrong data, and they're making business decisions based upon that. Now that's in some cases that might be a fireable offense. I would gave some wrong data to a company at Koch Industries. Who were they? Coke, either Coke Carbon or Coke Nitrogen. I don't remember which. And some people I worked at Coke were just top of the line. You could not find better people. And then there were some that weren't too good. And these people weren't too good. And I wasn't real comfortable with the calculations I'd come up with because my business knowledge is minimal. And I asked them to really look at the data or look at the reports. I meant look at the data. Well, they had a bunch of cosmetic changes on the reports, and I asked them how the data looked. They said, "Oh, it looks just fine." And it wasn't 2 or 3 months later, I got a call from them saying that the data was wrong in the reports, and they were upset because they've been making business decisions based upon this. It's like, well, that's not good, and don't know what kind of business decisions they made. I'd covered myself. I knew well enough. Like if you're having that conversation, you followed up with an email specifying you really need to have them look at the data to, and make sure that it's correct and so forth. And I had done that. You learn if you go to work for a place where you're giving them data that they're going to make business decisions upon. You need to cover yourself. Anyway, got that. Now if I shut that off. Should have had my phone shot before. I apologize. Okay, so for this one here, I did the setup we had before. So I pulled this information, and I said where my region dot region is equal to my sales dot region. Okay, now let me shut the phone off. I don't use my phone that much. Otherwise, I probably know how to do it while they were in the middle of calling. Okay. So, and you notice he gives us the same data over here. It excluded those values. So it isn't just that that one option there that gives you issues. Well, we're going to look a way around that. Okay. You'll notice here these, and I tried to keep it very close to this, so without having to redo a bunch of tables. So I did it upon region, just like they have here. And this first query here is what we've been running. So query one performs an inner join by specifying join as a condition in the where clause. This is the most significant difference between traditional and ANSI SQL join syntaxes. Take note of the column aliasing using the table.com. Okay, query two specifies join between the source and target tables as a where condition. There's a plus symbol and closing brackets to the left of the equal sign that indicates to Oracle that a right outer join must be performed. Well, let's see what difference that makes. You notice that I get the data now. Whether it has a corresponding link over there or not, it'll go ahead and pull it. Let's see. Does that make sense on the difference between those two? I don't know if that's true over here. Let me see. Okay, 196 records, customer. So I need to go delete a customer. Customer ID. I don't know if it's a number or not. Is a number, I guess. Okay, so now let me go back here. Now I'm only getting 166 records. So again, by the tables being out of sync, my reporting is off. Let's see if the plus is supported here. Doesn't like the plus. From orders, join customers using customer ID. Let's see if it supports that. Doesn't like that either. Of course, it helps if I spell. There it goes. Still came up with only 166 though. Oh, that's right, because that's the way that works. So, trying to remember if there's one. The plus is what I'm used to. I've worked with Oracle so long that these other ones. Outer join. What's the syntax of it? I don't think it's cross join. Let's see. No. I don't remember how to do it in regular SQL, to be honest. May not have an on or using. Could not prepare the natural join menu. Oh yeah, because it tries to. 166. It tries to make the logical connection based upon the column names. Okay. I guess I only know how to do it in Oracle. Let's see. Join using department ID or department ID. Okay. That's just talking about putting column tables in front of the columns names. Let's see, natural join countries, and again, it tries to determine itself the appropriate connection. I think I've ever used that natural join. I don't really like it. I wouldn't recommend using it because if somebody comes on later on and adds some fields to your table, if you're not specifically telling it, then is it necessarily doing it right? Okay. Took a look at that. Join to another table name using, and then the one connects them together. You can do your join, and by the way, E is just a shorthand way, so you can just type E.employee ID instead of doing the entire employees. And join is just discussed to demonstrate using two tables. There's no restriction on number of tables can be joined. Third normal form consists of a set of tables connected to a series of primary and foreign key relationships. Traversing these relationships using joins enables consistent and reliable retrieval of data. However, there are instances when primary and foreign key relationships are not defined between tables. These tables can also be joined, but the results do not benefit from referential integrity being enforced by the database. See, there's a bunch of different joins here. So you're taking employees, joining the departments, joining the locations, joining the countries, joining the regions. So that brings up a good question. Let's do a natural join. And, shippers. See here at the end, it's putting a shipper name and shipper phone. So natural join is a very quick way to connect them together. But again, if somebody changes your table for some reason, then that might break your query. This is a more safe way to approach it. If you do your join instead of a natural join, you tell how it's connected together. So you join employees to locations based upon L.location ID equals D dot location underscore ID. Even though they're the same, this specifically outlines it. So if they add two more columns that are the same, then your query won't be broke. non-equal joins. Non-equal joins match column values from different tables based on an inequality expression. And I know it's kind of small, but from employees E, join jobs J on 2 times E dot salary is less than J dot max underscore salary. So again, the on can have more elaborate selection criteria. Now, this next part talks about a self join. So join a table to itself using a self join. Storing hierarchical data in a single relational table may be accomplished by allocating at least 2 columns per row. One column stores an identifier of the row's parent record, and the second stores the row's identifier. Associating rows with each other based on a hierarchical relationship requires Oracle to join a table to itself. This self-join technique is discussed in the next section. So bizarre. Let me create one. I know, because I don't have this. I don't have a table to create it to show this. Okay. My employee number and 5. Employee name. I don't think I've ever had to do this in real life. Well, no, I don't think. I know I've never had to do this in real life. Okay, so remember leaving that as column. Sure enough, I did. Must be changing the wrong thing. Father number. I'm missing something. Column 2 is fine. I'll leave it that way. Okay. Why is that not changing? I hate computers. Go live up in Alaska in an igloo, and I don't know what they'd do up there. Why didn't I like that? Father number. Hmm. Uh, my, do you see anything I'm missing? Change it. Was that it? But that one time it did change. Maybe you're right. Maybe refresh. Or of course, one thing would change. I have to. Back to simple. Okay, now this is gonna drive me crazy. Let me see here. I could live with that one, no? Sometimes it changes, sometimes it doesn't. Okay, that's nice. Anyway, I'll go with the what. Since I couldn't get father number to take. That was that's their example, by the way. You got your father ID, and you're going to link it back into the table because your father works at the same company as you, for example. Okay. Okay, so that's David. My father is employee 3. Frank, and leave that as no. Employee 3. My dad's name is Paul. Um, 4 and Sam. Okay, so let's attempt to link it back to itself then. So my employee. Okay. So, my employee dot employee name. Employee number 2. Employee number see. Since I'm not that familiar with it, I'm going to use their example. So f1.name and then f2.name. So the f1 and f2 refer to our aliases for our tables. So select star f1.employee our name, and then f2 dot employee name from family f1. So from my employee f1, join my employee f2 on f1 dot employee number equals f2 dot employee number. That's not working. Select F1, name dad. This is an employee. Dad. Oh, what am I doing? What? That was where I put place the father ID. And so then links back into itself. Actually, that might have been something I could have used. That been a very practical thing, because the problem I've always had trouble with here at Cali is having a relationship like this, where like in the fall semester, spring, and fall and then spring, we have people take a class that was called pre-algebra, then elementary algebra, and then intermediate algebra, and then college algebra. And we really wanted to treat these as like one record, but there are 4 separate records. And it was just always a very challenging proposition to do that. But if you had one record linking back into itself, then that might be possible. I don't know. But anyway, that's a joining a table into itself. Okay. View data that does not meet a join condition by using outer joins. Sometimes you're trying to see the problem areas, for example. And I don't know if I can use the Oracle syntax on this or not. Can't do it in both places, I guess. But let's see. A left outer join performs an inner join of table 1, table 2 based on the conditions specified after the on. Any rows from the table on the left of the join keyword excluded for not fulfilling join conditions are also returned. And that's what we showed with the plus. I'm wondering if there's any way, what I'm wondering is if there's any way you can return what's on the right. Because obviously, when I did that, we could see the null ones. It's like when you did this, then you can see the null ones that don't have any kind of parenting. Okay, that's better that direction. Because Frank didn't have a parent there, and Paul didn't either. So then the question becomes, where? I'm wondering if I can put this in here. We'll see. F2 dot what equals, or is it equals or is null? Say equals null. Is F2, F1. Okay, yeah, here it is. So by playing with that a little bit, we're able to get all the records that are bad. So then we can go and fix those. Sometimes as a computer programmer, this is what you have to do on a fairly regular basis, like once every month or two. And when you do it, you have to really think about your SQL at that point. Because they tell you the database is messed up, and you're trying to figure out how in the world do I get the records that are screwed up. We had one database, and you think the databases should be perfect. There's no errors in them. You'd be shocked at how much garbage is in the databases, from user input incorrect, from bad programming, from a lot of different areas. We had one record, one table had to do with sending out emails that I don't remember if I wrote part of the program. If I did, it's embarrassing because it had so many error records we'd have to clean up that it was just wasn't even funny. It had to do with our email server not being reliable, and so when they would send out emails to potential customers, and potential customer wouldn't receive the email, like they'd be following up on a sales lead, and they'd be emailing back and say, "Hey, I saw you expressed interest in spectrum analyzers." Um, well, they weren't very happy when they didn't get that email. It looked like IFR had never contacted them, and so we had a system set up one point in time where they sent these emails out that is stored into a database. And then when our connection was decent, it would send the emails. It worked real fine and everything, but again, it wasn't written quite correct. I'm not going to go through all those different types. It shows a cross join. Okay. So chapter 11, subqueries and set operators. This will be the last of the SQL. We don't go into SQL as much as the SQL class. So we'll be getting into some of these other items, managing instances and Oracle networking, Oracle storage, Oracle security. Some of this we can actually show with a free version we have. Some of these are more geared toward the full product. So we'll see what we can do. The rest of it just may have to approach it from a different standpoint. Because we don't have a full Oracle installation here, Callie. Okay. Now these are subqueries. Subquery is a query that's nested inside a select, insert, update, or delete statement, or inside another subquery. And these are kind of different. Select sysdate today, and select count star from employees, department count, select star count star from employees, employee count from dual. Never really did very much with these either. Never had to write I guess subquery might work out pretty decent. That example I gave you about having math classes in 4 separate records. But, okay, select sysdate. Okay, from dual. Okay, and then count inside of parentheses. I need a comma there. Yeah, I do. Because it is just a column. Select count star from my sales. Tells us there's 44 records in my sales. Now let's try to do something like select region from my sales. See, single subquery returns more than one row. The reason why we have the count here is that will just return one row. Selecting region returns multiple rows. Select employee number. Employee name. From my employee, where employee number equals 1. Notice here, I picked something that only has one record coming back. Now, I mentioned that this might be good for the example I gave you here, because there's potentially only one record for pre-algebra, one record for elementary, and one record for intermediate, and one record for college, except that they could take college algebra more than once. they don't do well on it. So that summer, they take college algebra again. And I want to get maybe the most current one. There's a way to limit this, and I'm drawing a blank on what it is in Oracle. So I'm going to Google it. Oracle return first row. Order by fetch, next one row only. Okay, so let's do that. That right there should give us an error. It does. And then we'll throw a fetch on there. Fetch, next one row, rows only. Okay, so that would return one only. But then the question is, which one would it return? If I order by units, let's do that. Select. Units from my sales. Order by units ascending. Doesn't seem right. Select star from my sales. Descending. Oh, wait a minute, I'm looking at the wrong one. 2. I was looking at 44. I was like, oh, that ain't right. 2. Two is the smallest one. Okay. So I'm wrong where I said don't see where I could ever use that. That would work in here. If I want to get the most current college algebra, most current intermediate algebra, most current elementary algebra, most current pre-algebra, then I could use this right here. Now SQL is something you can learn fairly fast. It's a fairly simple language. To get good at it, to understand how you can really use it to its full potential, takes a while. It takes a while to master that. I have to admit, a lot of times when I want to do something weird, I would just export it to Excel, and then I would write VBA code, since I can easily go line by row by row in VBA and go back, sort it, and so forth. Okay, where's my book? It talks about the ones And you can read that, but I already talked about the one that can solve is where you link in the back end, or this isn't linking the back end itself, but I think it could. Select star from my sales. My sales dot item. Yeah, looks like your subquery can pull whatever information off of that. Um, um, state, comma, Too many values. um, that's interesting. Too many values. I was wondering if you could do a subquery inside of a subquery inside of a subquery. Okay, got com or hmm. Could be I'm just doing it wrong. But I'm not sure why you want a subquery within a subquery within a subquery. But part of me to play with this is I just want to explore this, challenge you to think outside the box. Try to think about what you can do with it and so forth. Let's see. Generate a table from which to select. So, employees assigned to a department. Departments have a location. Each location in the country. How can you find the average salary of staff in the country even though they work for different departments? Okay, so I select from those. That returns these. It looks like it averages the salary that you're pulling back here. Could be wrong. Interesting. And you can use it on inserts and so forth. Okay. And some of this I still want to show. Unions are important. Intersects important. We got 4 minutes left though. I'll leave that I'll leave that for the project for this week. So out of what we covered, which was the SQL joins and subqueries and set operators. So SQL joins, the subqueries and set operators. Create 10 different queries. You may have to create your own tables demonstrating these items. Now, I'm not real picky about it. If you got a particular join you want to do, I'm fine with that. Subquery, you can see that you can just do the simplest ones. Do something besides count, though. And then the set operators. I want you to do the union and intersect off of that. But 10 different ones out of that. Questions on anything? Okay. Well, we'll go ahead and stop there. Have a good afternoon, and I'll see you in the next class.